Hello, everyone, and welcome once again to the 31st installment of 96 Boards Open Hours, sponsored by Linaro right here. And today we have a very exciting episode. So since I've heard that there are some people in here, they're first timers. For those of you who don't know, my name is Robert Wolf. I do work for 96 Boards and Linaro, and this show goes on every Thursday at 8 a.m. Pacific Standard Time, 4 p.m. UTC. So tune in, and you're in for a treat every week with some very cool things. Right. So today, what are we covering? Today, we're going to be talking to Linaro's very own Bill Fletcher, coming to us from the Linaro global headquarters in the UK, Cambridge, UK. He's here on the call right now, and we're going to introduce him in just a minute. But as the Open Hours usually does, we're going to talk first about what we talked about last week. So we're going to kind of just give a little brief synopsis of what happened, and then we'll move into today's show. So last week, what did we do? We talked with Andy Clark. He was a very special guest to us because he's been kind of, I guess you could say, around the block with some of our single board computers here, and he's done quite a bit of work with the Dragon Board 410C and Qualcomm. He was actually voted the Developer of the Month by the Qualcomm Developer Network. And I'd like to share, actually, Christine, if you don't mind sharing some of these links from last week. We have his blog post, and then we also have his GitHub account. We have, we can probably share his Twitter. I'm sure he wouldn't mind people following him on Twitter. He does post some really cool stuff, and he does retweet a lot of really cool things. And then we have the Qualcomm Developer Network blog post as well. So feel free to check him out. That's Andy Clark from Workshop Shed. It was great having him last week, so thank you very much. And we hope to see him sometime in the future. I heard he's working on some other really cool stuff. Other announcements in the works right now. We will touch on this a little bit more at the end of the show, but as you may have heard, we have the Linaro Connect coming up. Registration has opened, so you can go to the Linaro Connect website and register. Lots of very cool things going on there. Every 6 months or so, approximately, we have an amazing convention somewhere in the world, and it just changes every time, right? So please check out that website. We'll talk about this more at the end of the show. Great. So why are we here today? Today, I just want to let everyone know that although we do these interviews and we talk with very cool people about very cool things, this is very informal. So feel free to interrupt us at any time. With your questions, anything, and even if it's not about the topic, and we'd be glad to answer them. I see the chat's lighting up. I'm not sure what's in there, but we'll talk to those in a second. All right, so getting started. Mr. Bill Fletcher, how are you today?
I'm very well, thank you, Robert. How are you?
Excellent. Yeah, so holidays are around the corner, and we really appreciate you not taking, the last 3 weeks of the month off. Most people like to do that, but thank you for joining us today. We have some pretty cool stuff that you're going to talk about with us, and I wanted to kind of first, this is what we do. You were on this call, gosh, man, probably 25 episodes ago.
Yeah, I think I was like number 6 or number 7, something like that.
So we have that YouTube video actually in the links right here. So Christine can probably share that too. But for those of you who are interested, it was so much fun. We talked about Docker running on the 96 Boards Consumer Edition. You can kind of see the lineup up here, these Consumer Edition boards. And it was a very interesting show. And it was one of the first shows, like Bill just said. So please go check that out. It was a lot of fun. You can run. Bill pushed out a blog. Bill pushed out instructions on how to recreate everything he did. So there are also links to that as well that we'll share. Check that out. So does anyone... I wanted to open this up, but did anyone have any questions for Bill on Docker before we kind of dive into this new subject?
Well, some kind of memory test you're thinking here, are you?
Yeah, for me too. But
yeah, no, that's cool. We'll go into Mqtt.
Actually, if anybody's interested in Docker, Tyler Baker has published a great blog post on LinkedIn about getting some of the latest Docker stuff up and running. So if you're into Docker, then PM me or Tyler just to get that stuff, because there is always plenty of stuff going on in that space.
You are on IRC, right, Bill?
Yeah, I'm on everything. Yes, I'm on IRC.
What's your handle on IRC? So if anyone wants to talk to you about Docker?
B Fletcher.
B Fletcher, there you go. So on IRC.
There we go. That's an easy one.
Excellent. All right, so let's dive into today's topic, right? We're going to talk about MQTT, and I have a million questions about this because I don't really know much about it. I've never messed with it. So maybe we could start this off by, you could kind of tell us a little bit about what you're doing with MQTT and maybe what it stands for.
Yeah. So I'll give you a little bit of a primer on MQTT, and I've got a little demo that happily happens to run on a 410C, but will run, I think, on pretty much any CE edition board. I've got a few words, a few little diagrams. So I'm going to share my screen now, if that's okay. So let me just figure out how to do that. And oh, great. So there's now going to be a slight pause. So do you see my? Okay, right. That's great.
Yeah, just loaded.
Awesome. I'm just looking for the turn it into full screen top right. Present. There we go. Is that good? Can everyone see that?
You definitely see it. I think we'll get some thumbs down if other people can't, but I'm sure it's good.
Okay, well, let's. And I think you still see me in a little window at the bottom. Is that right? Should I be careful that I don't do anything embarrassing? I'm thinking that you can't see me.
There's a slider we can choose how big your head is versus your slides.
That's an interesting conceptual thing, right? Okay, I'll let you play with that slider and maybe poll you to see where it is at the end of what I've presented. Okay, so 96 boards, MQTT, primer, and demo. So the punchline of what I'm going to talk about today is a little demo that I've put together that installs and runs MQTT. It installs a broker, message clients on a single 96 board C edition, just to demonstrate the protocol working. So what I'm going to talk about, I'm going to give a quick primer on MQTT. I am going to tell you what it stands for. I'm going to maybe mention a few cool things about MQTT that even if you did know some of the primer stuff, hopefully something interesting there. I'll talk a bit about MQTT implementations, and then I'll talk about the demo itself. And feel free to ping me, interrupt, cheer, boo, whistle. If you received any musical instruments ahead of the holiday season, then feel free to perform as I'm talking. Okay, so 101. MQTT, you want to know what it stands for, right? That's what you asked, Robert. So I'm going to tell you that it stands for MQ Telemetry Transport. And now you're going to tell me you want to know what MQ stands for. Am I right?
Yes.
So MQ stands for something from an IBM product, which is not actually included in MQTT. So nobody mentions. And it actually stands for message queues, but there aren't any message queues in MQTT. So the MQ kind of is something that we don't expand on. So if you're explaining MQTT, just telemetry transport. What's very important about MQTT is that it's becoming very common in the IoT space. It's part of Amazon's IoT offering. It's part of IBM's Bluemix offering, and many, many others. If you go and Google MQTT, go and look at the standards page. It's an international standard. It's kind of everywhere. And it was originally written for oil pipelines way back when. If you imagine an oil pipeline kind of going through the desert for hundreds of miles, there's no cellular connectivity, there's no IP connections. Everything is very low data rate. Maybe there are some surface cables, maybe it's via satellite. So it was for very inhospitable environments for data transmission. So it's designed for low power, low bandwidth, and even not very reliable applications, which makes it great for the IoT. And what's at the core of MQTT is what's called a publisher and subscribe model, or pub and sub if you want. So you have clients who publish messages and they can subscribe to messages, and everything goes through a central point, a central node, a central entity called a broker. So the two things that you maybe want to kind of have in your mind is clients, and they've all got connections to something in the middle called a broker, which moves the messages from people who are publishing them to people who are interested in subscribing to them. And MQTT messages are really, really simple. They have a string that tells you what they're about, and this is in ASCII, it's readable. They have a payload, which is just the stuff you want to send, and then maybe a few optional flags that manage stuff, which is called quality of service information. So first of all, it's optional, so you don't need to care about it, but it manages things like maybe you care about whether the message ever gets to the destination or whether it gets there more than one times. You know, are you worried about duplicate messages? And the way that messages pass through the system from the publishers to the subscribers is the topic string. That's kind of the be all and end all. The topic determines where the message ends up. Now, this is different to HTTP, which is like you make a request and you get something back. It's very similar. I don't know if there's anybody on this OpenHours session who's used the robot operating system, but the robot operating system and other systems of that kind have a publisher and subscriber model. So if you're familiar with that, MQTT uses some similar concepts. Is there anybody here who's used something like ROS?
So I haven't personally used it yet, but I've seen it in action on the Turtlebot with the Dragonboard 410C running at ELC San Diego. It was pretty cool. Also, we had a talk on ROS with Morgan Quigley at the last Linaro Connect. That was really cool. There's a video on our YouTube talking to him about that too. Maybe I'll share that in a second. But really good stuff there. I mean, it's still, and it's growing really quickly too. It's the open source robotics software, by the way, for people who don't know what ROS is. It stands for Robotics Operating System, I believe.
Yeah, exactly, and it has a similar messaging model to MQTT. So it's if you've used ROS, then it's interesting. If you learn about MQTT, then hey, you can reuse what you learn on ROS. So I drew a picture of the publisher subscriber model just because some people like me prefer it as a picture. So here is at the center a broker. And then I've got a publisher and I've got a number of subscribers. And I've got some little pink arrows which let you know the order that things kind of happen in MQTT.
Bill,
and the first thing that, yep, sure.
So someone asked in the chat, I'm sorry, Tyeth asked if this is similar to an event-driven model.
Yeah, it is event-based. So I'll talk a little bit more about how the message timing happens, but yes, the short answer is yes, it is.
I didn't mean to interrupt you. There you go.
No, it's cool. It's very cool. It's great to be interactive. Really great.
All right,
so just on the diagram, the pink arrows. So the first thing is that one or more subscribers subscribe to a topic string. So they say, I'm interested in this. Topic string could be first floor heating, or topic string could be oil pipe pressure, or topic string could be basically just any ASCII string that describes the kind of message. The broker registers the address of the subscriber and the topic string they're interested in. And then the next thing that happens is that a publisher, another client, publishes to the broker a message with a topic string and a message payload. And if the topic string matches what the subscribers have subscribed to, then the broker forwards that message to the subscribers. So that's the third pink arrow. So subscription, publishing, and then later subscriber will receive the message if the topic string matches. So a very simple model, event-driven, So and it's, as I say, not like HTTP. The subscribers don't pull. The broker pushes information when it has it to the subscriber. If there's any questions on that, I'm not going to, this is a bit of an eye chart. I'm just going to, that's actually kind of a little bit of text which explains what I just said. So if we post this maybe on the blog or something, then it's, you got the words there.
Yeah, so I know you said that you have a demo coming up, right? But I'm trying to kind of conceptualize this into possibly a use case using these 96 boards, and I'm curious what you're going to be demoing. But I mean, so we've seen, or the idea behind these 96 boards and connecting to each other, for instance, you're saying we have the broker and then we have subscribers. Could we picture a broker being like a consumer edition version of the 96 boards and then one of the subscribers being one of the IoT versions?
So quite often you could have something like, you know, the publisher could be something like a 96 board IoT edition, which has got a sensor on it for temperature or something. And then the broker could be a CE edition, so it could be distributed on a number of boards. And then the subscribers could be, you know, it could be a display connected to the CE edition board, or it could even be something, you know, something over the internet in the cloud, which is subscribing to those events remotely. Okay. So the whole system can be distributed up. So I'm just going to talk about you know, the underlying mechanism, because basically everything can be distributed over IP. But yeah, I mean, if you imagine that it could be a mixture of very small sensors, you know, maybe based on IoT edition boards. The broker could be a gateway to the internet, which, you know, a CE board would be something very suitable for that. And subscribers could, as well as being nodes in your house, could be, or factory or farm, could be, you know, something which is running on maybe you know, Linaro's developer cloud. You could run an Mqtt subscriber, which is subscribing for information that your IoT device is producing, passing through your CE device gateway up to the dev cloud.
And when looking at this case with the pipeline scenario, basically what you're doing is you're just daisy chaining these all the way across the country, for instance, right? I mean, and it's just passing information back and forth because you have no other hub, right?
Well, that's the thing, is that, I mean, the oil pipeline is an interesting case as to why this came about. The oil pipeline kind of envisaged that, like, maybe on every valve that controls that pipeline, you'd have a sensor as the valve open or closed, and then each of those valves would communicate up to, probably via a satellite, as to whether the valve is open or closed, but using MQTT, and then the broker, your central point where that came to, would be in a control center somewhere. So that was how it was originally envisaged. But it doesn't have to be an oil pipeline. It can be sensors, maybe for the crops that you're growing in your field, or it can be, you know, your sensors around your house for, I don't know, environment or security. And you know, the broker can be connected anywhere. It can be connected in your house as a CE board, or it could be via satellite, you know, and running, again, something like the dev cloud. The essence being that because the messaging model is so lightweight, it can run over anything.
Awesome. And so Mad Dog right now just asked in the chat, he's asking if you're going to discuss security. You did just mention it right now. Is there one of the slides in there on security?
It's a great question. The payload for MQTT is totally free form. So they don't mandate, you know, it's clear text, it's ASCII, it's binary, or it can be something which is heavily encrypted. So this is purely a telemetry transport, and the payload security is up to the implementer. So MQTT doesn't mandate it. In fact, you know, it's best to see security as a layer that you would put on top of this. And that's what I believe most IoT implementations do.
So Mad Dog asks now, he says also, what guarantee is there that the message actually gets to the broker and to the subscriber?
Okay, so there is no guarantee, and in fact, it's designed for unreliable networks. There is a simple quality of service mechanism where you can state that you want a message to get there 0 or more times. That is to say, it's kind of you don't care that much, and that's the default. You know, it's kind of best endeavor. Or you can set the quality of service to say, keep retrying until it gets there at least once. Or you can set the quality of service to say, it's got to get there once, but I don't want you to duplicate it. So obviously then there has to be an acknowledgement come back to say, yeah, okay, I got it. You can shut up now about this. So there are some very simple mechanisms on top of the basic protocol to manage that the message does get to its destination. And in the case that the subscriber is offline, then the broker will buffer the messages until the subscriber comes online again. Ultimately, for a lot of these sensor use cases, the expectation is that you may only get a percentage of the messages. You don't get all of them. Maybe your heating sensor detects the temperature every 5 minutes, but you only get because of unreliability, noise, or something, maybe you only get a message every half an hour. And in some cases, that's okay. But yes, there is the quality of service mechanism, so you can mandate that you're going to definitely get the message. Good question.
Yeah, so Tyeth wants to come back to security here. I know we don't know what's on the slideshows, but he says, I heard of Mqtt-LS or something when reading about Mqtt and other supported transport mechanisms on the ESP32. I presume this is the layer you mentioned as optional in implementation. The layer on top of the Mqtt would be the security.
Okay, so if I could just kind of go on with the slides, because I think that I do actually address, I picked that point up.
All right, cool. So we got it.
So, I mean, the point that I just make on this slide is that the Mqtt is standard Mqtt is based on top of IP. So there's an assumption there's an IP connection between the clients. Every client has to have some kind of IP stack. Every Mqtt client opens a connection to the broker, and therefore it has a permanently open socket connection. And the clients obviously don't connect to each other; they just know the broker. So just the kind of the sort of cool background stuff for Mqtt is it's not just a point-to-point protocol, because if you have multiple subscribers, they all get the message. So, for instance, if you want to, I don't know, if you've got some kind of place where in movies where something bad happens, then all the red lights go on around all the doors and the windows, and obviously you want to do that, so you've got to broadcast the message. Intruder detected, turn on the flashing red lights around all the doors and the windows. Then all those indicators will be subscribed to that message, that topic. You send it, and everything would get the message. The broker would send the message enough times to get to all the subscribers. It's very low overhead, and it's designed for small payloads, a few bytes to a few kilobytes. If you're looking for something to send streaming video, Mqtt is not what you want. Mqtt is the status of sensors, maybe a very low res image from a camera or something, but small packets, low overhead, low energy, those kinds of use cases. But the payload can be anything. So on this security topic, Mqtt doesn't mandate. That the payload, as long as it's below the minimum size, it can be binary, it can be encrypted, it can be plain text JSON, it can be anything. And the topic string it can have a hierarchical structure. There are a couple of slashes in that example: heating, first floor temperature, and you can wildcard it. So if you're interested in all the temperature readings, you can go wildcard temperature, and you get everything. If you're interested in just things that happen on the first floor, you can subscribe to topics which are wildcard, first floor, wildcard, and you get everything for the first floor. So it's, it gives quite a bit of flexibility in how the subscribers can interact with the data they can get from the broker. And as I mentioned, it handles unreliable connections. The broker buffers until the connection is restored. Now, someone on the call mentioned MQTT SN. I think that was the variant. Am I right? I can't see the chat, unfortunately.
So it was MQTT LS, but he said or something. So maybe that wasn't it.
Okay, so LS, that I don't know. I'll have to go and Google that one afterwards. SN is for...
I was about to say, I think it's TLS, so it's Transport Layer Security. So in addition to encrypting the payload and managing your security on that nature, you can also put the protocol on top of secure sockets, and then things like the password field in the Connect gets encrypted automatically. I think that's what MQTT LS will be. Okay,
for sure, yes, you can, because it's just standard IP. Then you can do that. SN is for sensor networks, and it's even lower payload overhead than standard MQTT, and it doesn't mandate IP. So that's something that you would use on very, very low energy, low capability devices. So the topic string gets abbreviated to just a few digits, and the broker has to manage the connection method, which is potentially non-IP to any of the it's assumed that they would be low capability sensor nodes. Okay, so there are quite a few implementations of MQTT. So there are, if you Google it, there's Hive is a commercial implementation, and there's a lot of good information about the protocol on the Hive website. There are some excellent open source projects, a couple of Eclipse projects which I'm using in my demo today. One is for the message broker, and it's called Mqtt. Mosquito being a word that cunningly includes the letters MQTT. There's also an Eclipse project for a client, so that's a subscriber and publisher called Paho, and they're related open source projects on the Eclipse website. And there are client bindings for Python, Java, certainly, and probably quite a few other languages, but Python and Java are the ones that I've seen, and Python is the one that I used in my demo.
Cool.
So, if there are no more questions about just that little primer, I don't know if there's anything else on chat. I'm quite happy to be contacted afterwards. If anybody's using MQTT out in the field, then obviously we'd be very interested in any war stories. This is really a demo just to kind of get the protocol up and running. What I did in this demo, you're asking about use cases. In this case, I'm actually using Twitter as a source of MQTT messages. So my publisher is a gateway. So it's a gateway from Twitter, using Tweepy to read tweets, and then republishing those tweets on an internal network, actually just running on one board, which has a subscriber which is subscribing to those tweets but receiving them over MQTT.
Yeah, so there is a question for you on the chat. Maybe we can get this before you go into the demo, if you don't mind.
Yep.
So Kieran asks is there payload compression support, such as since it's a TCP connection header itself is 40 bytes plus the payload.
So so from the point of view of what I've been doing with MQTT, I've been using MQTT, and out of the box over a standard network connection. And in fact, even in some cases, not even over a network connection, but between clients and a broker running on a local host. To be honest, that's not something that I've dug into, but it's certainly an interesting topic.
All right. Well, I mean, I guess let's do the demo then.
Okay, so the demo is up and running on, and my assistant, my technical assistant, Chauvin, has actually got it on his machine. So if I stop screen sharing, then it's quite possible that Chauvin will be able to show the demo.
Yeah, that's fine.
Okay, so the only thing is that maybe Robert needs to switch from you to me, from me to you.
No, so do you want me to pin Chauvin? I can pin him. Let me see.
Chauvin. Yeah, pin Chauvin. There we go.
All right.
All right. So, so I'm just going to move Chauvin's laptop. We had camera problems at the last minute, so we're using multiple laptops here. So here's my Dragon Board 410. Which is running a recent Debian image.
Nice.
And then, okay, so what I've got, I've got a message publisher on my monitor, which is basically a gateway between Twitter and Mqtt. And so what you're seeing in the terminal window here are actually tweets that it's receiving. So it's authenticated. It's using via the Twitter APIs. It's using Tweepy, and it's pulling any tweet which has got the word Linux in it. And then if maybe you can just about see that. And then it's taking those. It's using the PAHO Python bindings to then publish those tweets as MQTT messages to a Mosquito-based MQTT broker running on the same machine. And then I have a number of PAHO subscribers. I only have one enabled at the moment, which is on the right-hand side of the screen. And I've got a little GTK window, which is showing what that's receiving. So it's receiving MQTT messages. The topic for the MQTT messages is Twitter/96 boards. So that's the topic string. That's on my internal MQTT network. And then you're seeing the payload, which is basically the payload of the tweet. So that's running on 96 boards on a CE edition 410C. It should run on any CE edition board that's got a recent Debian install. The scripts to install this are on my well. There's actually a project page on 96 boards, so this project is actually shared as a 96 boards project.
Yeah, I have the link right here. I wanted to share that. It's MQTT projects right here. So you should have enough information based on this project page. There should be enough information to recreate this, right, Bill?
Absolutely. So yeah, I referenced a particular build that I've tested this on 410C. If you pull that and then take my install scripts, then but barring the usual gremlins, that should just work and get you up and running with that demo. And then my suggestion is that this is a springboard. So if you wanted to then move either the publisher or the subscriber off that CE board onto something like an IoT board or onto another CE board, so maybe you had a remote sensor or a remote display or some remote processing, then that will be the next step. There's a settings file within the demo which allows you to specify what the IP address is of the broker, so that you can actually have communicating over IP. And if you've got an account in the dev cloud, or you wanted to run something remotely in the cloud, then there's no reason why you can't share messages across that sort of connection.
Okay, so a question came up in the chat, but I kind of had one of my own here. If someone, I guess, a little bit more savvy with Mqtt was interested in getting into the development side of things. So I mean, we're kind of approaching it on the novice side of things, where okay, I'm going to go follow your project's page and I'm going to get up and started, and then from there I might go to more advanced items. But I mean, if someone was interested in developing or contributing, is this something that's open for them to do?
No, absolutely. But both Mqtt and Paho are open source Eclipse projects.
Okay, and then you said that that's available on the Eclipse page, right?
Absolutely.
Okay,
yeah.
Cool. So for anyone who's interested in the community to contribute, that's also something that could happen, making it getting started and making it more adaptable, coming up with some more cool projects for 96 boards.
Oh, for sure. Well, I mean, we're very interested to see anybody who's communicating across multiple boards. I've not yet seen an implementation on an IoT edition board, but I guess that's something that we could look at next.
Yeah, so the IoT boards, they're running Zephyr right now, right? So that means that these particular packages would have to run on Zephyr.
Yeah. Well, I mean, obviously, once you've got an IP stack on there, and I think that's pretty much done for Zephyr, then running Mqtt on top of that is not such a big deal once you've got basic network connectivity.
Well, cool. No, the demo was awesome. Thank you very much, Bill, for showing us that. I'm excited to go in there and check out the projects page to see if I can try recreating it myself. There is a question on the chat here. I'm going to read it to you real quick, and this is from Tayeb. I really hope I'm pronouncing that right. But so I wanted to do Wi-Fi config over infrared. Would MQTT-SN be suitable, or can someone recommend a better route to follow? So then he gives a kind of a use case. So imagine Raspberry Pi or Dragon Board as controller distributing over infrared the Wi-Fi network details and its own broker info to a couple of ESP32s with infrared receivers. Is that?
Well, I mean, I think that I mean you still need. For MQTT-SN, okay, there may be some extensions that might make that possible. Certainly for straight-ahead MQTT, then you'd have a problem with not being able to have a two-way connection.
So, I mean, I'm guessing like the way I would imagine it is you would have, for instance, a Dragon Board as your gateway, almost so to say, or your broker, and then multiple other boards around your house. Like say I wanted one little IoT device, or he's using ESP32 to turn the deadbolt on your front door or open your garage or something. I mean, like, or sense something, input or output.
Yeah. Or even multiple ones making awesome decorations on your Christmas tree.
I don't even want to.
It makes things connectable.
Yeah.
So I think a very simple war story I can offer was a friend's wedding who had built himself some LED art, which was driven by an ESP8266. So you had multi-addressable LEDs, and he had all these light effects going on. And other things around the reception venue would publish messages to it. So, for example, if the people over in the camera area took a picture of themselves at the wedding with his kind of pre-supplied camera thing, then the light show would go all sparkly because it was just able to catch that message and react to things that had happened. So that kind of plumbing of simply getting things to interact with other things is easy and very, very hackable. And so you can, whenever you've made a small project that has some comms in it, you can make it more hackable and more able to build something more exciting by adding MQTT to it.
That's cool.
Yeah, absolutely.
Sorry, go ahead.
No, I was just saying, and the wildcarding means that you can, if you want something to react to a subset of the messages, you can make it quite an interesting subset because you can react to little bits of the topic string.
Nice. Yeah. So I guess Tyeth just added, yeah, the infrared is to initially set up boards, then switch to Wi-Fi. It's for budget Nest device. Yeah.
Right.
I mean, sounds like it's possible. You're gonna have to get in there and just dig around, right?
I'm thinking you'd roll your own protocol. For infrared, you just keep shouting the message over and over again with a sync word until you catch it. Then you take it out of config mode. You wouldn't have a protocol on top. You'd just constantly retransmit a fixed message with a clear sync word in it so that the receiver can spot the sync word and catch it.
Cool. So does anyone have any more questions for Bill Fletcher here? Or Bill, did you have any more things to add to this?
I just have. Hey.
Oh, go ahead.
Yeah, I just have one last slide on the demo, which is what it is. So if I just stick that up on the screen. So yeah, so in the demo, there's just a script to start it. The broker runs in the background. The publisher and subscriber are a couple of Python programs. The little GTK-based window is a service which runs and gets the things to display over RPyC. All the settings are in a single settings.py file, which has the addresses, as I mentioned. If you want to put the broker on a different board, then you put the IP address of the broker in the settings file. The topic string is in the settings file. The OAuth info for the Twitter API access is in there. So then the gateway file is streaming mqtt.py, and then there's a subscriber which actually puts things up on the GTK window, and then there are all the install scripts. The source code is up there on GitHub. It's tested on a Dragon Board 410C with build 144. But it should work on any Debian-based CE board. So I'm very happy to hear back over IRC or ping me by email or any other mechanism if you've got any experiences with this or any more questions.
Yeah. So this is tough. I'm trying to see how I can word this, but there are a couple posts on the 96 boards forums. I want to address those, but we are slightly pushing on the time here. Before I address forum posts, I wanted to say that we are going to take all of this information, and with Bill's permission, will we be able to write a blog and put this slideshow up for everyone on the call? Yeah. Okay. Cool. So we'll take the slideshow. We'll put that up on for everyone. Does anyone have any more questions for Bill? Because there was a couple things that I wanted to address as well around 96 boards questions that were brought up last week. But before that, we could any questions for Bill on Mqtt? People are having a lot of technical difficulties with their name displaying still. I know it's Sushant had a question about anything. Can Mqtt be supported on Android?
Yes, it is supported on Android.
Okay, so that hopefully answers that question. Okay, great. So Bill, thank you very much. We really appreciate this. We'll definitely get a blog written up, and we'll post that slideshow up. But that was not my question. Do you want to post that question again then, Sushant? I'm sorry about that. Or you can speak up if you like. No? Great. Well, Bill, thank you very much. John Mark, I know I have you in the call here. There's someone I brought in to talk to you about some stuff. But before we do that, I'm going to I guess, sorry, glitching out a little bit here because I have my cats running around in the background. Okay, so yeah, John Mark, Daniel Thompson is in the call right now. You had the question on the Android, and unfortunately, I don't think it's going to be good news. You were talking about addressing certain issues regarding the UART running on the mezzanine board with Android. And so, Daniel, do you have any news on that? Because I did share that forum post with you.
Yeah, no. Essentially, we've got to the stage where we know it's not hardware because I did the tests on Debian. But on the Android side, you know, I don't routinely use Android. But the problem we have at the moment is it's a different kernel, different set of serial drivers to the ones that appear in the mainline kernels and in our own kernels, the Debian kernels. And we don't really know whether the problem you're seeing are due to the way we've opened up the serial port in Debian. So whether it's a user space issue that we've opened the serial port wrong for some reason, some of the settings on the port, or whether there's actually a fault in the driver itself. It seems more likely, given that all the serial ports will be the same and some of them work, that I would assume it's going to be on the opening up side. Things like hardware flow control are a particular risk. But I've got no obvious way to help you narrow down on that I can come up with straight away. Obviously, if you can demonstrate on a C program that you can compile both for Bionic and for Debian, and we see it work on Debian, see it don't work on Android, that's quite a clear smoking gun. But that's the bit that's difficult for me at this stage is to figure out whether it's the kernel and its different driver, or whether it's to do with the way the serial port's been opened by the user space.
I understand. Okay, thank you. Yeah, we will see that in the future. Maybe some idea will show up, and it's not a very important problem, but it's too bad that we cannot communicate through the UART port between anything from outside. I mean, we have to use the Bluetooth. I use the Bluetooth now anyway, so. But I would imagine put the Bluetooth on the mezzanine just to talk to the Dragon board, which is a bit ridiculous. So.
Yeah.
You know, I don't want to have a Bluetooth on my mezzanine just to talk to my Dragon board. I think the Dragon board should be able, in serial communication, to be able to communicate from the external. And any plug-in board like the mezzanine should be able to connect and talk serially. There are other ways. Maybe I should use the I2C and OSPI or the other way, but it's too bad because the UART is already there. So too bad we cannot use it.
Yeah, so the issue, we'll keep poking around. I mean, eventually, hopefully something happens, but it eventually boils down to, I think, Qualcomm, right? I mean, they're the ones who make this image.
You know what? I had such problem on microcontrollers when you make a wrong clock subdivision. For the speed, let's say you want to work 9600 baud and you don't divide correctly the clock, the base clock. So then it looks like the system is acting the same way. So sometimes it can see a letter and sometimes it cannot see the ASCII character. Sometimes it can decode it, sometimes not. So that the garbage I'm talking about, that's a matter of fact, are the characters I'm sending over. And sometimes it can see some characters and sometimes not. But this would be hardware in that point. But as said Daniel, it is not a hardware problem in that case because it's working on Debian, which is the same hardware. So it must be a driver. I agree with Daniel. It must be a driver handling or something else. Is using the UART 0 on interrupt and things like that, and they corrupt in case I don't know. Anyway, something should come up once. It would be a nice thing. Thank you. Anyway.
Serial ports are far more complex than you'd ever believe at the software level. They're actually very simple pieces of hardware, but the software and protocols pushed over the top are astoundingly complex. And the kernel support, if you ever look into the depths of the serial drivers, is far, far more code than you would imagine at first sight. I mean, particularly one key problem we did recently with one of the 96 boards was the serial port was wedged into 7-bit mode because the parity bits had been misprogrammed. This wasn't a quad-board, but that meant that whenever you tried to send data that was outside the classic 7-bit ASCII range, it wasn't receiving the right character, which is a notorious to accidentally be in 7-bit mode. And then there's lots of little nuances like that, and it's why I can't really arbitrate blame between your code and the kernel at any point.
Thank you. Anyway.
Well, we'll keep poking around, John Mark, and then also there's also the option of pinging Qualcomm, bringing them in. Hopefully, maybe we can do something with that as well. And you're very responsive on all the emails and everything. So, you know, bringing them in requires quick responses. Maybe we can start working on something like that offline.
Sure. Thank you.
Right.
Thank you. Thank you, Daniel.
Thank you. Thank you. So I wanted to just address one more question on the clock, and then we'll switch over to after hours. But last week and then the week before, I think something was brought up around Opencl, and this was talked about as to its use on Debian. Now, we've already said that it works on Android, but Daniel is here once again, and I think we had some sort of, again, probably not a good answer, or it's a good answer, but not the answer you want about that.
It's a fairly authoritative statement, which is that Opencl does not work on Debian builds. The hardware is Opencl capable, but the Debian builds are using a reverse engineered driver, and certainly as of August, the reverse engineering was most of the way there, but incomplete, and was not actively worked on in August. So eventually, the guy called Rob Clark, who's done all this reverse engineering, hopes to get to it, but it's not in any sense planned. It's not on a roadmap. He's not paid to do it. You know, he may eventually get to it because he likes playing with this stuff, but not for any other reason. So that's where that stands. It's not a roadmap. It's something that's being thought about, but it's not in any kind of roadmap or any kind of date. Desperate developers could play with things like libhybris, but you could sink a lot of time trying to bring up the Qualcomm driver on top of libhybris. So libhybris is a mechanism to try and exploit Android hardware support from regular Linux. So it's the library that things like Ubuntu mobile use and Jolla and other things. So it's got some background, but there's very little getting started documents. So certainly I would not be overjoyed at the prospect of supporting somebody doing it. It would be a try it on your own and see where you get to. So anybody who's really desperate could play with that. But I think the simpler answer is that it is not currently supported, and no discussion of dates is possible.
Okay, cool, great. So I mean, we're kind of coming up to the hour now, the end of the hour, and thank you everyone for your questions. I wanted to get to the last bit of announcements, and we are fortunate enough to have Mad Dog on the call today. So I would also like to ask him in just a minute to maybe announce next week's call where he will be participating, if you could give us a little intro to that. But real quick, let's kind of just summarize what happened and talk about those beginning of the show announcements real quick. So this week we met with Bill Fletcher, right? He talked to us about Mqtt, nice little presentation. If anyone has any more questions, I'm hoping maybe Bill can stick around for another 10 or 15 minutes after the call. Do the after hours, talk about some of that stuff. We do plan on pushing out a blog, providing his slides, and you can always visit the projects page to recreate the demo that he showed us. Bill, did you have any last closing remarks there?
No, thanks very much, and Merry Christmas.
Merry Christmas, Happy Holidays. Thank you so much for participating in this call. I was really grateful here at Open Hours. Thank you. I want to remind everyone that if you do have a Twitter account, it would be great if you followed us on 96 boards. If you are interested in following me, you can follow me there as well. Sushant, I'm going to address your question in the after hours right now. So if you just hold on for 1 second, I'm sorry about that. Also, we started a new mailing list. Now, this is a very interesting mailing list. It's got the weekly output now. So our old mailing list, 96 Boards, has thousands of people on there. We'd love it if all the thousands of you moved over to our new weekly digest, but we do promise to keep it to 1 email a week at the most, which means you won't get more than 4 a month, but it's www.96boards.org/newsletter/digest. That should be the link there. 96boards.org/newsletter/digest. Hope I spelled that right. Hope it takes you there. Let me see. And we're good. So yeah, fill that out. Join our weekly digest newsletter. And then I would like to give a second to Mad Dog real quick, if you don't mind talking to us about next week, what we got going on for us. Christmas special, surprise.
Sure, I'd be happy to do that.
Awesome.
My name is John Mad Dog Hall, and I've been in the computer space for 47 years and been in the Linux space since 1994. I'm working on a series of different projects, mostly down in Latin America. One of them has to do with bringing in small single-board computers to Latin America. But there's recently a article that showed that Brazil was one of the most expensive countries in the world for electronics due to things like taxes, import taxes. And so projects like the Raspberry Pi suffer from that, because the Raspberry Pi that in most of the countries of the world you can get easily for $35, in Brazil can cost up to $150. And so our project is to bring in manufacturing of these small computers to Brazil. And I naturally lean towards ARM processors. And in the long run, we want to kind of concentrate on 96 boards. So this would be a country with a population of 194 million, which is about half of the United States. And we think that we could have a very good educational and hackerspace program in Brazil, which emphasized ARM processors. I have reasons for liking the ARM architecture, which I can also talk about during that presentation. Another thing which we're doing is I'm working with the University of Sao Paulo. They have 100,000 students, 16,000 PhDs. And I happened to mention to them one time that a GPU could actually be created utilizing a FPGA. And they thought that was an interesting project, so they have done it. And I can talk a little bit about that project. I can also talk a little bit about the issues of manufacturing a board if you start from the very beginning and go through, or if you just even start from a design with parts. And a lot of people don't appreciate how much work it takes to bring something like a single board computer actually to market. So these are some of the things I could talk about. And if anybody has any other ideas that they would like to discuss or issues that they would like to discuss, that'd be fine.
Yeah, so I'm pretty sure we're going to bring up quite a bit of questions around comparing. I would really like to compare 96 boards to other SBCs on the market. So I'm pretty sure we can have quite a bit of a conversation on that. I hope people would be interested on that as well. But thank you, Mad Dog, for explaining that. We will address this next week on OpenHours. I am going to stop the recording now, though. So everyone, we look forward to seeing you next week. Thank you so much for participating. Please stick around for the after hours where we can continue to talk and ask questions around 96 boards. Thank you so much. Take care. Happy holidays.
Sure.